first and foremost, to be excited about it, you have to believe in nuclear energy. And you have to think that it is the solution to a lot of the critical problems for the country. And one thing that's fascinating about working with nuclear engineers, I'm an astrophysicist by training, and I got involved in nuclear energy years ago when I went to Oregon National Lab, is that people, probably more than any other field I've dealt with, really care deeply about the problems they're solving, and they believe deeply in them. And they will stop at nothing to see through what they think the correct technological solutions are to help the country. So I think starting with that, you have to really believe in the technology, and you have to believe in what the technology can do for our country. Secondly, you have to like solving very hard problems. And this is one of the deepest problems in all of physics, because when you really boil it down, the question of, if I perform a computer simulation of a model of this very complicated phenomenon, what are the barriers, and how sure can I be that the simulation that was performed represents reality? And how can I use that information to put this new sort of paradigm to use in a practical sense? Okay, so it's a very deep question. It sort of gets to the heart of predictability and determinism, chaos, and a lot of the fascinating fields that emerged in the latter half of the 20th century. But the real key question then is, how can you, one, understand these potentials and these limitations, and at the same time, how can you use this to your advantage, given the reality of the potential and the limitation, to actually solve a problem which could change the world? And when you put the two together, it is a lot of fun.